Hello, my name is Ethan Fisher, and over the course of today, as I give this presentation, 1.04 million tons of plastic waste will be generated by the world, 8.4% of which will be recycled according to an EPA study conducted in 2017. But what if there was an easier way to reuse more plastic? As a civil engineering student at the University of Pittsburgh, sustainability is a common issue that is brought up alongside the issue of America's aging infrastructure. "We need civil engineers now more than ever" is a common phrase I hear from many of my department's professors. And when the country scored a D+ for overall infrastructure in 2017, according to the report card study the American Society of Civil Engineers performs every 4 years, they're probably right. Luckily, civil engineering firms are aware of the need for improved infrastructure, and some are finding that the solution might be in our plastic waste. So again, I ask, what if there was an easier way to reuse plastic? Let's go to the presentation. Plastics can be recycled, but it is a costly and inefficient process. Most plastic waste is usually put into landfills, incinerated, or polluted into the environment. Landfilling and incinerating plastic are both problematic methods of managing plastic waste. Additionally, plastics in landfills can leak pollutants into the surrounding soil. Currently in the civil engineering field, there are 2 potential uses for these waste plastics, and I will go over them now. The first use is the use of global plastic waste in the construction of a product called plastic road. This is a product realized by 3 Dutch companies, KWS, Wavin, and Total. Each is a market leader. One is in road construction, the other recycling of plastic, and the third making plastic products for rainwater drainage. As a team, their product came together and tackles the issue of plastic waste and infrastructure reparations in a variety of ways. Plastic Road is 100% circular in nature, reusing plastic waste and its old components in its creation. As such, it is expected to last 2 to 3 times as long as that of traditional road paving and be constructed 70% faster given its modular design. In this model that you can see in the left and right images made by KWS, Plastic Road would have a hollow space built in to allow ease of wiring, connecting pipes, and other facilities to homes, such as water and gas. And the plastic waste that's used comes with various chemical and physical properties that can be implemented in the product to meet the specific requirements of different roads, such as weather conditions and the wear resistance. But Plastic Road isn't without its disadvantages as well. Because of its pure plastic design, it requires that the recycled waste plastics be compatible, because when plastics of different types are melted, they might phase separate and cause structural weaknesses that can potentially lead to premature failure of the product. Also, once again, due to its pure plastic composition, the plastics in the road can break down into microplastics that can find their way into soil and bodies of water as contaminants. Finally, probably its most overlooked disadvantage is the fact that every time maintenance is performed on these modular roads, any facilities that are run through the road, such as power, water, or internet, will have to be interrupted. Another solution to global plastic waste has been developed in India and will be referred to as plastic roads throughout this presentation. These roads take the current manufacturing process of asphalt, depicted in the slide seen before you, and they replace the bitumen portion with a plastic bitumen composite. This change in the process brings along its own advantages and disadvantages to the paving process. These composite roads do not need to be as discriminatory with plastics used as the plastic road. This allows for increased reuse of many plastics and avoids the labor-intensive segregation process of plastic waste by not having to worry about different types of plastic phase separating in the melting process. Also, this composite uses less asphalt as a whole. which saves on cost and resources, especially when petroleum is becoming such a finite resource. And once again, since plastics come with various chemical and physical properties, these plastic roads can be engineered to meet specific requirements. However, the major pitfall of this solution is that it still requires the use of petroleum and doesn't use as much waste plastic as plastic road per cubic foot. So, what if we compared these two options? Due to the labor-intensive nature of manufacturing plastic road as a product and the continued testing that is still required of this product, I propose that a temporary solution be adopted in which asphalt manufacturers produce plastic bitumen composite style roads until plastic road becomes a more viable alternative to waste plastic reuse. One company in Scotland has actually done just that and uses anywhere between 3 to 10 kilograms of waste plastic in each ton of asphalt that they make. This waste plastic is specifically transformed into the patent-pending polymers MR6, MR8, and MR10, which are bituminous binders designed to improve the strength and durability of asphalt and reduce the quantity of bitumen required in the mix. And because of the method of manufacturing used to create these three polymers, they contain no microplastics that could potentially harm the planet. These polymers, if adopted across the world as a whole, will use millions of tons of plastic waste currently sitting in landfills. It will reduce government spending on new roads, maintenance, and pothole repair, and also ensure roads are made stronger and longer lasting. So, as I said at the beginning of this presentation, what if we made reusing plastic easier? Well, then we might just improve our infrastructure as well. Thank you.